Hi, how's everyone doing? Thanks for being here. It's, I know, a long day of the second day, so I appreciate everyone being here and still having that energy high. So I'm Inez. I work at Block on our developers productivity team, specifically for Android. And in my talk today, I want to talk about flaky tests, how we deal with them, the progress we've been able to make so far, where we are at, and where we are going. So I will first explain just so we're on the same page what the flaky tests are for us, talk about how we dealt with them initially when we didn't realize how big of a problem it is, then talk a little bit about the evolving solutions, which we have a number of, and wrap up with some impact and some charts. So just quickly about the flaky tests. We just define them as the tests that intermittently fail. So sometimes they fail, sometimes they pass, not necessarily having to do anything with actual change into the business logic. The problem is that they really erode trust in our build system. And that also translates to other parts of the developer environment. If they don't trust the build system, they start not trusting other parts. That creates a lot of headache for planning the capacity, a lot of demand for our CI pipeline. Also, just people sometimes, if they have a flaky test, but they start with the retrying it without investigating the cause. So potentially, it's a lot of time they waste that they could be using for something more productive. So to add a little bit more context about Block. So at Block, we have multiple mega repos. Think of them essentially as the monorepos, except that there is more than one. So we have one for our Android code base. We have one for iOS. We have one for JavaScript, one for backend, one for Golang, maybe a couple more. And on top of that, we have thousands of smaller repos. So, but there may be 5 to 7 of the main mega repos. We also have multiple CI systems. We have Kuchiku. It's something that we started building about 10 years ago, and we keep building it and improving. It served us great. It's an open source project, a little bit abandoned, but if you're interested, I encourage you to take a look. We also use Jenkins and a couple other systems. And on top of that, we also have multiple data pipelines. So we have multiple repositories running on different CI systems. And then we have to send that data somewhere, but we also send it, depending on the project, to different places. So that's the context explaining why it's a little bit challenging, even from the perspective of trying to understand the problem and the impact. So our initial response when we started realizing that there are flaky tests, they actually impact developers. That's around the same time when we basically started investing into DX, a couple of years ago, and DX wasn't yet necessarily a big thing at our organization. We started by creating a script which basically allowed people to, at least when they encounter flaky test, make it easy for them to ignore that test. So it's a little bit naive solution in the sense that they can just add the ignore annotation to the test. But there was a friction of a developer wanting to make a progress, being annoyed by a test that gets in their way, that is flaky. But if they disable it or they remove the test or just commented out the entire test, that experience was not very consistent, and it was annoying other developers that were relying on that test. So just creating a common standard of how you disable a test, and that script creating a ticket in our case in Jira, so the team owning or partially responsible for that test was notified about it. At least let us get on the same page in sense of having a process that if the developer productivity decrease, they know what to do to recover. So I will talk a little bit about evolving solutions, what we did later. So and before we go to that, I'll just show an example of our scripts creating those ignore. Nothing very sophisticated here, but just consistency. When we ignore the test, we always put the link to Jira. People can from Jira quickly find out what's the flake rate of that. They understand why it got ignored. So there is, it basically removes some conversation. It creates a process and clarity. Here I have a little bit better example, or a little bit more sophisticated, where we actually started using LLMs to try to find out why the test is flaking. So it does not only disable the test, but actually suggest the developer, the one who potentially would be fixing it, that what is the potential problem. And this is a pretty good example because here it is actually very much spot on. It was the missing call to defer for unlocking mutex. So LLM did really, really well here. And I think we're going to be leaning more into that in the future. But basically, we're trying to automate that. It's not just ignoring a test, but actually showing that potential solution or more context about the problem. So stress testing. That's another evolving solution that we're experimenting with. So when people create new tests with the previous solution that I described, they often would find out a couple days later that those tests are broken or flaky, maybe flaky, not broken, because it takes time for the test to actually run multiple times to generate the metric, for us to pick up that metric and see that it is flaky. So in some of our repositories, we started recognizing when there is a new test and running it multiple times. We currently experimenting with running tests, depending on the repo, at around 100 times. So it's a good solution in terms of like preventing introducing new tests, new flake, but it has its own challenges. I will talk about it a little bit later in this talk. Moving on to common reasons of flakiness. That's, I think, the big insight that we had, and it allowed us to make a huge progress in this area. So specifically, a lot of tools in the industry for flaky test or for test analytics in general looks at the test as a main entity. So at the class name and the test name, and that's the main entity. And we talk about that test flakiness or eventually that class flakiness. What we started doing was looking at the stack traces of the failures. And then we found out that actually a lot of tests are failing with exactly the same stack trace. And that let us solve a couple hundred flakes at once. Here is just kind of pseudocode, but this is the normalization for the stack traces. It will be different for different repos and different use cases, but it's basically to take a stack trace and remove all the non-deterministic values or some integers. It's very, very simple here, but it was very powerful. Like without this kind of normalization, we were not able to see any of the trends and patterns. And then even after applying simple normalization like that, trends and patterns emerged, and we were able to make a great progress. This could be, of course, much more sophisticated, but just showing that with a small, relatively investment, couple regexes, you can make a great progress. So that allowed us to later also start looking into advanced detection of new flakes. So what I mean here is detection of flakiness is tricky because a lot of tests flake for different reasons, and some of those reasons don't have necessarily to do anything with the test, but they might have to do with the different levels of infrastructure. In our case, it wouldn't be just the infrastructure on which we run the test, but I'm talking more about robots pattern, like which we use on Android, or even the application itself, like different parts of application being maybe non-deterministic in some cases. So how it connects to the advanced detection of flakiness is that we are trying to look at new reasons for the same test to flake. So don't look at the flake or the test as a major entity, but actually track separately rates of flakiness for the test for different reasons. And when the same test start flaking for different reasons, then we want to notify the developer. And that's the big shift that we are still haven't finished, but it allows us to provide that information to developer at the very actionable time. It's when they are actually still have the pull request open, they're still working, making a progress. So it's before they merge it, before they wait a few days or go on a vacation, and then they find out like, oh, their test got disabled. Other solution which we are implementing or implemented to an extent is the eager test suppression. So you remember when I earlier talked about disabling flaky test. So because we made that change in the code, it is problematic because it does not apply to the branches and pull requests that have not picked up, have not yet rebased that change. So our systems already realized that there is a flake, it has to be disabled, the relevant team got notified about it, but people that have not rebased, they're still affected by it. So it is very, very not ideal. It also led to the situations that people sometimes would observe non-deterministic or flaky behavior in the CI, and they would rebase because they thought that would help for some reason. So what we did is actually starting providing non-hermetic information to the CI. So when we disable tests, we put that information into database, and then we run builds. We fetch the list of the tests that should be skipped. So therefore, like if we find something is flaky, essentially that information is propagated to other developers immediately. And dynamic retries. So in a lot of systems out there, you can configure retries for tests. We do that. That allows tests, of course, to become flaky, but also it allows developers to stay productive, that they are not affected by those flakes. And in a lot of systems, those retries are static, which is problematic because if you actually have a legit failure or a test that is perfectly stable, you end up retrying it multiple times before you actually notify the developer that there's a problem, that there is a failure. So essentially, you're wasting time and resources. So we started looking into the historic information. There is an example of the problem. So there are 7 actually runners here. Those are UI tests. There are 7 emulators running. And in the last 3, you can see a lot of failures. So actually, test kept being retried, even though it was actual test that will never succeed. But if we knew that ahead of time that it's a stable test, we would not have to retry it at all. And as you see in this case, the test would finish much earlier. So we shifted to dynamic retries, which is basically considering the historic flakiness of a certain test in the decision whether how many retries it should get. So the tests that are stable are getting 1 retry or 0 retries, and that also frees up the resources that the flaky test or very flaky test can get more retries, so they succeed and developers are not negatively affected. And of course, that has to be done in conjunction with the other solutions, so we don't let all the tests just increasingly forever become more flaky. Here, just to touch a little bit on the impact of our improvements. So basically, I want to show that after we started implementing some solutions and releasing them recently, our CI became the most reliable it has been in a while. It's just for one repo, but here you can see that it's around 3 to 5%. So those are new solutions that we are rolling out. We are still driving that reliability down, but that's roughly where we are at now. Here is a different look at the similar split, basically, between the flakiness and other reliability issues. So those are the solutions that I described briefly that we are experimenting with and that we implemented. But kind of like taking a look at our strategy. So our strategy is to actually stabilize the situation first. So make sure that the number of the flaky tests is not increasing. It's rather stable. And then we want to go after fixing the flaky tests, which this is work in progress, but we are setting up programs where a group of developers will be able to hopefully work efficiently on unflaking many tests. So the things like I mentioned before, the stress testing, things like that are very useful, because then if actually people get dedicated effort to work on that, we can make sure that they work in a productive manner. And I think that's all I got for our group today. So thank you very much. And I don't know if we have time for questions, if there are any, but if not, I will be hanging around. So thank you very much.